Hey guys, my name is Trevor Sullivan and welcome back to my video channel. Thank you so much for joining me for yet another video in the Rust programming tutorial series. Right now we are continuing with our learning about the fundamental concepts behind the Rust programming language. Now, we are building upon some previous concepts with this particular video. We're going to be talking about iterators. So I'm going to point you over to the documentation for the iterator type in the Rust standard library documentation here, which you can find by just doing a simple Google search for Rust STD. And if we go down to the standard library crate and then go to modules right here, there's a whole bunch of child modules that are packaged up as part of the standard library. One of those modules is called the iter module here, and this iter module may seem kind of inconsequential at first, but it actually contains a lot of core functionality that allows us to work on data types that are of types collection. So, for example, if you look back at some of my historical videos in this playlist, which you can find right over here on my channel, this is the Rust programming tutorial. We're actually going to be building on top of some concepts like the option enumeration type here, which can either have some or none values. So make sure you go back and watch that video. Also, you'll want to understand what closures are. So closures are basically anonymous functions, but I've got a 30-minute video that covers that topic as well. So having an understanding of some of those topics is really going to help you to better understand how to work with iterators. Now, if we go over to the traits section right here, we have this trait here, which is kind of like an interface in other languages that declares a whole bunch of methods that work with any data types in Rust that implement the iterator type. So if we just click on the iterator trait right here, on the left-hand side, you'll see required methods right here. So these are any methods that are mandatory for implementing the iterator trait type if you're implementing it on a custom type. But then under the provided methods heading right here, there are tons and tons of different methods available out of the box in Rust that allow you to manipulate data inside of these iterators, iterate over the data, of course, itself as well, and also kind of tracking your state inside of the iterator. So we're going to go through some of the essential functions inside of these provided methods here to better understand how we can work with iterators in Rust. So right up here, we've got the next method right here, and this basically just allows you to go to the next item in a collection of items. So in one of my earlier videos, we talked about the vec data type, and this is similar to an array, but it's kind of a dynamically expanding array where you can just add items onto the end of it. So it's a really common data type that you'll probably be working with in Rust in order to create a collection of items. Maybe if you're building like a random data generator, you have a list of first names or a list of last names or a list of cities or a list of some other entity within the world to represent some real world data. And if you want to iterate across each of those items or maybe filter that collection of items, then these iterator methods that are implemented here on the iterator trait are really going to help you to work with and manipulate that data. So next right here just basically advances to the next item in the iterator. All right, so what we're going to be doing is going into our sample project here. Previously, we worked with hash maps and hash set data types. That's the previous video coming in the playlist before this video that you're watching now. So we're going to go ahead and switch over to our main.rs file here, and we're going to comment out any of the calls in our main function here to the my hash set or my hash map modules that we created for this lesson here. But before we actually create the module, I just wanted to remind you that I am an independent content creator, so please subscribe to the channel. It really helps my channel to grow. Please share a link with anybody who you think would be interested in learning Rust fundamentals. It's a great language, very high performance, very low memory utilization, and it allows you to write efficient applications. So hopefully we'll see the Rust programming language grow over time. Please leave a like on the video by the end if you learned anything new, even just one little thing, and also leave a comment down below and let me know what your thoughts on this particular video are. All right, so what we're going to do is go into our project here and simply create a new file, and we'll call this test, or maybe my iterators.rs. And then we need to declare that file as a module in our main file here, because the Rust compiler only takes one input file, which is our main.rs file. And then the main.rs file can actually link to other source code files within our project by simply declaring them as a module. So we'll say pubmod myiters. And then inside of our main function here, right down at the end, we will call any function that we create inside of that module. So let's start by exposing a function from the myiters module. We'll say pub mod test rust iterators. And inside of the body of this function, we're going to, actually, let's do pub mod fn. I was wondering why we're getting a syntax error there. I always seem to forget, it's actually pub fn. I don't know why I'm doing module there. Pub fn, test rust iterators. All right, so now what we're going to do is to actually create some data so that we can learn how the iterator itself works. So typically, I like to start with just a vector. Arrays also implement the iterator type as well. So feel free to use whatever works best for you, but I know that Vec supports the iterator type, and because it's dynamically expanding and it's a generic type that allows us to wrap any other data type, I just like to use vectors with the Vec macro here that allows us to easily instantiate a new Vec with any underlying data type that we want. So let's plug in some names here of maybe foods that we like. So I'm going to say, strawberry. Let's actually just call this fruit list. And we'll say strawberry, blueberry. We'll say mango. And then we'll say orange. And maybe just one more. We'll say apple. All right, so let's close that off with a semicolon. Now we have a vec of type pointer to a static string value. So let's say we wanted to iterate over each of these items and just, eat each item, right? So we'll just print out a statement that says that we're going to eat that current item, right? Well, because we have a vec type here that wraps another data type, it doesn't matter which type it is, we can get an iterator across this by going to the variable right here called fruit list containing that vec. And what we'll do is say dot iter, and this iter method here simply returns an iterator back to the caller, and then we can use that iter to control the data inside of this vec. So I'm actually going to assign the result of that iter, which is the iterator trait. If you just look at the help here, you can see it returns an iterator over our generic data type here. And so I'll just call this fruit iter, and we'll use a let statement there. And so this is going to iterate over each element of this vec. So now what we can do is typically you would just write like a for loop or something. So we could say for fruit in fruit iter, and then we could create a block of code here that does something with it, right? So when we use this syntax, we're actually using the iterator here to list over each item in the array. So let's just do a print line, put a couple curly braces in there, and then just pass in fruit. And then we'll go ahead and call that from main as well. So let's call test rust iterators from our main file here. So let's is my iters double colon and test rust iterators. All right. Now, if we do a cargo run, you can see it just prints out strawberry, blueberry, mango, orange, and apple, right? So this is kind of the most simple way of just iterating over every single element in the iterator and then just printing it out, right? But there's a lot more advanced stuff that we can do besides just iterating through every item from start to finish. Once you have a reference to one of these iterator traits, you can actually minutely control the iterator. So we don't just have to start at the beginning and go all the way to the end. We can do things like skip over elements. We can grab a certain number of elements. We can filter those elements. We can mutate those elements. There's a lot of different methods available in the iterator type over here, the trait, that allow us to control this data. And that's where all these provided methods are going to do. That's what they're going to do. So what we can do is say, for starters, let's just comment out this for loop here, or actually we'll just get rid of it. And what we want to do for starters is let's just grab a single item, right? So we want to iterate over all the items, but we want to directly control how exactly we do that. So the most simple way of doing that is just by calling the next method here. And next is going to just return the first item from the iterator so that we can work with it, right? Maybe we want to do a whole bunch of things with that very first item before we go on and process some of the other items, or maybe we want to conditionally process the item only if it starts with a certain letter, right? So I only want to process items that start with B, or only process items that end in a Y, or something bizarre like that. And remember that this works on custom structs as well. It's not just working on strings or numeric values. So we could actually have a vec containing user-defined structs like a person, a dog, a planet, or a building, or anything like that, right? So if we do next right here, this is just going to say, let's just do let num1, or actually let's just do item 01. I get a little finicky with my variable declaration types here. And as you can see, we are already getting this error saying cannot mutate the immutable variable fruit iter. And that's because when we start to manipulate the iterator, advancing to the next item, that's actually mutating the internal state of the iterator, because the iterator actually keeps track of where we're at inside of the list of data here. So the iterator basically starts at item 0, and then when we call next, it basically pulls the first element off of that array, or vec in this case, and lets us process it. So now that we added the mute keyword to the iterator itself, we can now grab this first item, and then we can just say, first item in iterator is X, and we'll pass in item 01, which is a string pointer, and we'll just convert that to a string because it's actually an option type here. So you can see we're getting an option to a pointer to a string. And so if we unwrap that value, then we can get the underlying string representation. Because again, if you go back to my video on options, you'll know that option actually wraps the underlying data type. So if we run this, you can see first item in iterator is strawberry. So let's say we wanted to get over to the third item, which would be index 2 if you're talking array terminology, right? Because we have 0, 1, and then 2. So if we wanted to, we could actually just do fruit iter dot next, and we don't even have to capture the value that comes back. All we're doing is advancing the iterator and effectively just discarding the data. We're not actually doing anything with the data. So if we wanted to get mango here, we could simply call the next method on the iterator twice. That'll cause it to skip over strawberry, skip over blueberry, and then the next item that we retrieve should be mango. So let's save this, run it, and sure enough, we get mango here. Now, there's a lot of other capabilities that we have with iterators. One of those cool capabilities is that if you have more than one iterator, more than one list of items or collection of items that you want to process, we can actually mash those together into a single iterator, and we'll take a look at how to do that now. So far, we just have a single iterator here, or a single vec, I should say, with a fruit list, right? But let's say that I had something else like nut list, and let's do another vec here, and we'll do walnuts, almonds, I don't know why I typed almost there, almonds, and then pecans, and we'll do Brazil nuts. All right. So now we have a second vec here. It still has the same underlying data type of pointer to string, static string value, but now we have two different vecs. So maybe I want to eat all of these different foods at the same time, right? So normally you'd probably think, well, I have to write a for loop that iterates over fruit list, and then I have to write a for loop that iterates over the nut list, right? Well, we don't actually have to do that. We can simplify our code quite a bit by using one of the built-in methods in the iterator type. And this method is called the chain method. So if we take a look at this chain method right here, it takes itself as input. So of course we don't have to pass that in because self is implied when we call that method on the iterator. But then the only argument that we have to pass into the chain method here is a pointer to another iterator. And so what that will do is it will return back to us a chain, which I believe also implements iterator itself. So if we take a look at the chain struct here, yes, it does implement iterator here. And so we can simply iterate over the results inside of that chain struct and retrieve the aggregated results from that chain method. So what we'll do is go down here and let's just say let's do fruit list up here for starters, dot iter, dot chain. So first we have to get the iterator from the fruit list, and then we have to get the chain method from that. And as you can see, it says expected one argument. So what we need to do is pass in a pointer to our nut list here. So let's do ampersand nut list, and we'll capture the return value, which is aggregate foods. All right, so let's see what we get here. So as you can see, the Rust compiler is able to infer all the data types here. So it is pointing to string values in our iterator here. Of course, it realizes that the chain type that is returned from the right-hand side implements iterator. So aggregate foods here is going to have an iterator. So now what we can do is iterate over each of the foods in aggregate foods. So say for food in aggregate foods, let's do print line eating X, and we'll pass in food. All right, so I think everything should be good here. Let me just add in a comment here that says testing.chain method, and we'll do cargo run. All right, so now you can see that with a single for loop, we were able to iterate over all of the fruits and all of the nuts. We didn't have to write two separate for loops in order to accomplish that because we chained them together using the chain method. And then, of course, we could take this iterator here that we got as a result, and if we had a third vec containing other foods, maybe cereals or something like that, then we could simply call the chain method again to basically tack on the list of cereals to the end of our iterator here. So this allows you to kind of take multiple vecs or multiple collection types that implement iterator, mash them together so that you can treat them as a singular entity. So that's a really convenient method to be aware of when you are working with collection types. Now, something else that's interesting that we can do is to take an iterator and turn it back into a collection type. Remember that the iterator is basically the thing that's tracking the internal state to determine what position you're currently at in the iterator. So what we can do is basically take that iterator and then just turn it back into a collection type similar to a vec here. So what we can do in order to accomplish that is let's do aggregate foods, which is an iterator. And then there is this special method here called the collect method. And this allows you to take your self, which in this case is an iterator type, and turn it back into a collection. So I don't think this takes any input parameters. So yeah, we just pass in self, which is of course the iterator itself. But then what you're going to see is that we have to specify a type annotation here. So it's basically asking us, well, what data type do you want to take this collection of items and turn it into? Well, we can do that on the left-hand side here. We'll say let all foods equal, because remember, aggregate foods is an iterator. It's not really a collection of items. It's an iterator. But then we'll do let all foods equal. We'll do colon vec string pointer here. And this should allow us to take those values and convert it back into this type. And it's actually going to be a double ampersand here, because if you look at the aggregate foods right here, it's actually got a double pointer here to string. So we would just use two ampersands within the vec here to indicate that that's the underlying type. And then anytime that we reference one of these string pointers, Rust automatically determines the number of derefs that have to occur using something like the asterisk character to dereference that into the underlying string data type. So that's how we can take a iterator and actually turn it back into just a collection. And then once we have that collection, like all foods here, we can actually then, once again, get an iterator across all of those elements. But if you ever need to take an iterator and then just turn it into some collection type, this is how you would accomplish that. Now it's complaining here because we didn't clone this. So if we clone aggregate foods, then we will not move the value out of scope. And so then we can use it once again inside of this for loop. All right, so that is the collect method. Let's take a look at transforming data inside of an iterator. So let's say that we've got this all foods variable here, right? It contains a vec, and let's say that we want to add fruit onto all of the entities here. Actually, let's do it on fruit list itself. So we'll do fruit list.iter. So this gives us our iterator. But now if we wanted to transform each of these fruits and put fruit at the end of whatever the fruit name is, so we'd have strawberry space fruit or blueberry space fruit and so on and so forth. Well, how would we accomplish that? Well, for starters, what I'm going to do is actually turn this vec of string pointers into capital S strings that are allocated on the heap. So what we'll do is say fruit list dot iter. And so we're going to iterate across all of these items and transform them from string pointers into strings on the heap. And the way that we can do that is by using the map method right here. In fact, I was going to use this method anyway to transform the data inside of the strings anyway, but we'll see how to convert the data type, and then we'll actually manipulate those strings inside of another map call. So map is really useful here. Let's take a look at the documentation really quick down in the map function right here. And you can see that we pass in f, right? So we have self, which again is the iterator itself, or the iterator item, I should say. And then we have f right here, which basically transforms the data by using a closure. And this is why you need to go back and watch my video on closures or anonymous functions, because this is how we adapt the data inside of the iterator here. So essentially what we are expecting here is a closure that defines a single input, which is the element that we are currently iterating on, and then a little bit of code here that indicates what we want to do to transform the data. So what we're going to do in here is just define an input argument of e, and then we'll just say string : from e. And so what that'll do is it'll take the pointer to string as input here, and then it should return a string data type. And so we'll go ahead and just assign the results of that to fruit list strings. And it looks like we are getting a little bit of an error here. So let's see what is going on. So it's saying that string from pointer is not supported. So let's see if we can deref e, and that should work fine. So basically we're just dereferencing the double pointer into a singular pointer, and then that is supported as a from type for the from method here on the string struct. So what we're going to do now is take this transformed list of items here, and then we're going to map them again, right? Because we haven't actually changed the string value from strawberry to strawberry space fruit or blueberry space fruit. We still have the original values. We've just converted the data type from a string pointer to a string capital S value. So then we'll take this fruit list strings, and then we'll map over it again. So we'll do actually, we already have a iterator, so we'll actually just call map directly on that. We can see right here that the Rust compiler has inferred the iterator type from the map call right here. So the map returns an iterator. So we don't need to call .iter. We can just do .map because we already have an iter. And then we'll take each element and we'll simply add a value to it. So we'll say e dot push, I think, and then we'll say push string, and we're going to push a static string of space fruit onto the end of each element. So then what we can do is just print out each of those items. And of course, it's telling us that it cannot borrow e as mutable here because our fruit list strings is not mutable, I think, or actually it's probably the argument on the closure here. Yeah, so I don't think fruit list strings needs to be mutable because we're not doing an in-place mutation. So let's call this new fruits, and we'll capture the results of this map operation here. And now we have yet another iterator, but new fruits, unlike fruit list strings, should have the mutated values, right? So we didn't just do a data type conversion from a static string to a string on the heap. Now we've actually taken each fruit and appended a static string value onto it. So let's just do a really quick for loop. And I'm actually going to show you another very, very helpful function, which is a for function that you can call on the iterator. So rather than saying for fruit in new fruits, and then putting our code inside of these curly braces, there's actually a very convenient helper method called for each on iterators. So we can literally just take this new fruits iterator that we already have and say dot for each. And then once again, we're going to use a closure or anonymous function in order to specify what we want to do with each element. In map, the difference is that we are actually returning a new value. But in the case of for each, we're not returning a new value. We're not transforming the data. All we're doing is performing some kind of operation with each element. So let's do a print line here, and then we'll pass in each item as E, and then we'll go ahead and specify E right here in a print line statement. And hopefully this will show us all of the fruits with fruit at the end. Looks like we're getting an error here, so let's see. Looks like we're passing in a unit type for some reason here instead of the desired underlying type. So let's take a look at for each here really quick and make sure that we are calling it correctly. So right down here we have for each. And of course, I have to make sure that I do an unwrap here, I think. I don't have an option type, I have a unit type. So let's see what's going on here. And I think I just identified it pretty quick here. So the reason is that right up here on this line where we declare new fruits, we actually have an iterator over a unit type. And so that what that tells me is that there's some problem with the map function here not returning the correct value. So we're not returning anything, which is causing the compiler to infer that we are returning a unit or none type, right? So not to be confused with option none, of course, but it's basically just an empty value. So e.pushString here is not actually returning any value. If I hover over it, you can see in the signature here at the very end, there is no return type. So we need to make sure that we are actually returning E back to the caller. So what we'll do is just specify a couple of curly braces here for our closure, and then we'll just do return E. I think that should satisfy it there. And yep, sure enough, now we have an iterator over string. And that fixes our error right here on our for each line. So let's save that and do a cargo run. And sure enough, right down here at the end, we have just the fruits, not the nuts, of course. And we have fruit showing up at the end. So map is very helpful because it allows you to transform the data. We could have done the data transformation appending this line at the end, or this fruit at the end here inside of the first map function, but I just kind of wanted to show you how to do that separately. Just kind of do one step at a time so we're not biting off more than we can chew in an individual step. So the first thing that we did with map was to take our vec of string pointer, convert it into capital S strings on the heap, and then those are a lot more flexible types that we can work with. And then in our second call to map, we just iterated over the same data once again and added this static string of space fruit onto the end of each item. And then we also learned about for each that allows us to simply iterate over each element within the iterator and do something with it. All right, let's see what other methods are available. So we've already looked at next, chain, collect, map, and things like that. But let's say that you wanted to grab something like the last element. So basically, rather than iterating across all the elements here, maybe we just want to get apple here. There's another helper for that. So if we do new fruits dot last, this allows us to simply retrieve the last element from this iterator, right? And this also consumes the iterator, which basically means that no other code will be able to use the iterator. And that's already happening here anyway when we called for each, because this for each I think is also consuming the iterator. So typically what I like to do is just do a dot clone, and that'll make a replica of the data that is dedicated for this particular call. And then I can do dot clone again here in case I need to use the iterator again in the future. And so now if we do a print line on this result right here for last, we should just see fruit. And of course, we need to make sure we unwrap the value as well. So we'll call unwrap on it, do a run, and sure enough, we only get apple fruit, right? All these up here are from the for each loop that we did, but then the final one here is just apple fruit. So we could also just say last fruit is colon and make that a little bit more explicit. All right, so that's the last function. There's also another one called skip by. And so this allows us to skip items. There's actually a couple of different, actually I meant step by, not skip by, but step by allows us to step over a certain number of items rather than just going to the next item. So let's say that you had a list of some kind of items and you just want to skip every other item. Well, you can set the step size to 2 instead of 1, and that will allow you to call the next method to retrieve every other item rather than every single item inside of the list. So using our fruits again here as an example, let's say we wanted to start with strawberry and then skip over blueberry, then get mango, skip over orange, and then get apple. Well, the step by is going to allow us to accomplish that. So let's do new fruits.clone, and then we'll go ahead and say step by. And this is going to return a step by object, which I believe implements the iterator type. Let's actually just confirm that right here. So we'll say step by, that returns a step by struct here. And let's make sure that that implements iterator. So over on the left, it says implements iterator. So we're good to go there. So let's come back here and say step by and set our size to 2. And then we'll do another variable here that says step by and put a semicolon on the end. So now step by here has a new iterator across our string values. And if we call println and just pass in step and say pass in the step by dot next value, and then let's just duplicate this a couple of more times. Of course, we need to do dot unwrap here as well. So let's clean up these extra lines, make sure that we're calling unwrap each time. It says we can't borrow it as mutable, so let's do mut to make that mutable. And now we can go ahead and run this. So as you can see, the first step is strawberry fruit. Then we would have normally expected the blueberry to be next because that's the next item in the vec here, but we actually get mango. Then we would expect orange, but we don't have orange because we set the step to 2 rather than 1. And then we have apple. So that's how we can set an alternate step. So if you have a data set that you're processing and whoever provided you that data set just happened to put an item at every second item or every third item or fourth item, whatever it may be, then you can use this step by to change which items you're actually retrieving from the collection type. So that's a very nice helper. Let's talk about zip. So again, let's say similar to chain, right? We talked about chain previously. And with the chain method here on iterator types, we saw how we could take fruit list and nut list and mash them together into a single iterator. Well, zip can actually do a similar thing where we can take a couple of different collections and mash them together into a single iterator. But the behavior of zip is quite a bit different than what chain does. All chain does is it takes the input and it puts it at the end of the first iterator that we called the method on. But in the case of zip, if you look at a zipper, like on pants or a jacket or something like that, you'll actually see that you have two sides, the left and the right side. And so those are staggered when you actually zip up the jacket, right? So basically, you switch between each side and you take an item from there and you go up the zipper, right? Well, the zip method basically does the same thing, only it joins together one item from the first collection and one item from the second collection into a tuple type. So then the result is going to be essentially a collection of tuples that are paired together. So let's do a vec here. So let's say let first names equal vec, and we'll say Trevor and Shannon and James and Tasha. And I also want to convert these to strings. So we'll just do first names dot map, take each element and return string from E and assign the result back to a variable like first names strings. All right, so let's do let actually. So now we should have a vec of string types here. Let's see what is going on. So we need to do dot iter here, of course. Iter, not inter. and then we can call map. All right, so now we have a vec of or an iterator of strings, I should say. And so let's create a last names. So we'll say last names. Let's actually just duplicate this down here and then say last names. And then we'll change last names here to Jones, Sullivan, Tanner, and Redmond. All right, so we have a vec of first names and a vec of last names, and we created iterators for strings over each of those. Let's just duplicate that there. So we have first names as strings and last names as strings on the heap. And now let's say we want to zip these together. So Trevor is Jones, Shannon is Sullivan, James is Tanner, and Tasha is Redmond. So what we can do to basically pair up these values is to call the zip method. So we'll do first names dot, actually we want first names strings, which is already an iterator, so we don't have to call iter on it. So then we'll do dot zip, and then we'll pass in last names strings, and that will, again, zip these values together. So it'll take one item from first names, one item from last names, it'll join them together as a tuple value, and then we can process this collection of tuples. So let's do let full names equal whatever the result of this zip function is. And as you can see, our iterator that we get as a result is going to iterate over tuple items rather than individual scalar string values. So now what we can do is take our iterator, full names, and say for each, which we've already learned about. And then we could do a statement here that says take e element and do a print line statement here and say first name space last name, and then we'll just pass in e.0 and e.1. Back in my video that I did on data types, you should know that tuples have 0, 1, 2, 3, 4, etc. accessors to retrieve each value from the tuple type. Also, the Rust compiler is able to infer the data type here for our input e parameter because it knows that we have an iterator over tuples with 2 string values inside of them. So that's a nice convenience that we don't have to write inside of our code. All right, so let's give this code a try. And it looks like we are getting an error here. And so again, I think we need to dereference where we have string from. Let's try to dereference E, and we'll do that again on last names. I think we're doing it as well. So let's go down to line 35 here and dereference first names. Okay, so now we should be good to go. Actually, we need to do last names here. Almost missed that, where we're referencing first names still. That's the problem with duplicating code and fixing it sometimes, but it does sometimes save you time as long as you know what you're doing. All right, so as long as this runs correctly, we should have Trevor space Jones, Shannon space Sullivan, James space Tanner, and Tasha space Redmond, thanks to the zip ability, which took one element from each of these collections and simply joined them together into a tuple type. So that's a nice convenience function that can allow you to take a couple of different collections, mash them together, but in this case, we get a tuple rather than having a set of scalar values that is extended like what we have with the chain. All right, so zip is really convenient. We also have another interesting method here called enumerate. And this is really simple. This doesn't really do a whole lot except rather than accessing each item from the iterator, we actually get an index as well as the underlying value from the iterator. So if we call the enumerate method on an existing iterator, like full names right here, then when we iterate over it, if we do for item in enumerate, we actually get a tuple type here. And so right here, we have the first element, which is the index of the value, and the second item is the value. And so what we can do is actually destructure this in a tuple and say index and value, and then we can use both of those values inside of our for loop here. So normally the difference here with the enumerate method is that we get the index and the value from Rust, whereas if you do a for loop just over a regular iterator of scalar values, then you don't actually get the index. You'd actually have to go look that up yourself separately. So enumerate just turns it into an index and a value. as a tuple type. And in this case, we actually have our value is a tuple inside of the outer tuple, which includes the index as a scalar type. So let's do a print line here and say index x and value is y. And then we'll pass in our index and our value types here. Of course, we need to make sure that we just grab the individual values here because we can't convert a tuple into a string. So let's just grab each individual string value and do value 0 and value 1. All right, so we have 3 placeholders there. The first placeholder is for the index, which starts at 0, of course. Second placeholder is first name, and the final placeholder there in our template string is the last name from our tuple type. So enumerate is really simple. It just gives you that extra index to wrap your data in here, just in case you need that index for some reason to uniquely identify each element within the iterator. All right, so we've already talked about step by. Step by allows us to skip items, but there's actually another way to skip items as well. So what we'll do here is say, I want to take my full names here. And this is already an iterator over our tuples that have been zipped together. And let's say that I want to skip over the first element of this collection of tuples. Well, the first one is going to be Trevor Jones. So let's say I wanted everything except Trevor Jones. Well, there's another helper method on the iterator type here that does exactly that. So let's go back to the iterator docs here and then find the skip method. And skip allows us to take a collection of items. In this case, they're just using a static array of integer values, but then we can get an iterator across it and we can simply skip a certain number of values. So what we'll do is come back here and say, all right, skip one item. And then we'll just do a for each on that. And then we'll take each element and do print line and basically just say, element dot 0, which should be the person's first name. I don't care about the last name at this point because we have unique values for each of those. So we'll just say did not skip item, just so we can uniquely identify those lines and do a cargo run. And it says did not skip Shannon, did not skip James, and did not skip Tasha, because we only skipped the first element there. If we skipped 2 elements, maybe, and run this, then we only get James and Tasha back because we skipped the first 2 items in that collection of items. So skip is nice if you have a collection of items and you know you want to skip the first item. You know, sometimes if you're processing data, you might have like a header row or something and you just want to skip over that header row. And if you're processing CSV data, for example, and so the skip element or skip method here allows you to skip over 1 or more elements within your data set. All right, there's another cool helper here called take. So what we can do is basically skip over a number of items, and then we can take a certain number of items after that and get a new iterator. So after we skip over 2 items, we can just chain these methods together because skip gives us an iterator as well. And this time what we can do is say, take this iterator where we skipped the first 2 items, and then take 1 item off of that new iterator. And then this time, what we're going to do is we're just going to get James. So right up here, we had Trevor Jones, Shannon Sullivan, and James Tanner, and Tasha Redman. But what we did is we skipped over Trevor and Shannon, and we just took James. But because we said take 1, not take 2 elements, Tasha was omitted from the results because we only took the first element from that new iterator. So you can use these and kind of chain these methods together. So I say, all right, skip the first 2 elements, but give me the third one, right? And then I don't care about any items after that. All I want is that third item in the collection. So take is another very convenient helper method. You can also do take while. So if you want to provide a closure to evaluate whether you should or shouldn't take a particular value, you can specify that as well. There's an example right here in the documentation about how to use that. All right, there's another interesting method called fold. So if we look for fold right up here, this is similar to another function that's very common in data processing called the reduce function. But in this particular case, what we can do is specify an accumulator initial value. So this tracks internal state as this accumulator. So let's say that we wanted to maybe total up items in a list, right? So what we can do is create a collection of items. Let's do a new item here called foods. So let's say we have a bunch of foods at a restaurant and we have a certain inventory of those foods. Okay, so let's do a vec type here and we'll create a couple of tuples here. So the first tuple will have potatoes and we'll say we have 10 potatoes. And then we'll create another tuple that says strawberries. And maybe we have 25 strawberries. And then we'll do a final item here, which is burgers. And let's say that we have 31 burgers. Okay. So now what we can do is basically total up all of these foods and say, how many foods do I have in total? I don't care what type they are. I just want to know how many foods I have in my inventory. So what we'll do is take this foods vec here, and then we'll say iter because we want the iterator from it. And then what we'll do is use this fold method here. The very first input parameter here is the initial value of the accumulator. And then the second is going to take a mutable input of our element within the iterator. And then we have a closure here that basically allows us to determine what to do with each element. So I'm going to go ahead and just specify an initial value for our accumulator as an unsigned 32-bit integer with a value of 0. And then in my closure here, the processing for each of these elements, I'm going to say E, and I think that needs to be mutable because that's what the function signature says. And then we're just going to take our initial value here and simply add it right back into it. And so the way that we're going to do that, following this example right here, it actually takes 2 input arguments. I forgot the first element is the accumulator itself. So let's do A as mutable. And of course, the element doesn't need to be mutable because we're not actually mutating the element. So then we'll just say A, which is the accumulator, plus E dot 1. And you might be asking why E dot 1? Well, the items that we are iterating over here are tuples, and each of our tuples has 2 values, 0 and 1. So the quantity of these tuples is in the second element, which is index number 1. So we basically want to take the accumulator that starts at 0, and for each item in our collection of tuples, we want to grab the second index, which is 1. And then we can take the result of this, and the data type is actually inferred based on the data type that we're feeding into our accumulator, which is this case a unsigned 32-bit integer. So let's say food quantity is the result. And as soon as we save that, the Rust compiler should infer that the result is going to be a U32 because that's what our accumulator is. And it's basically just returning the final value of the accumulator back to the variable here. So then we'll do a print line statement that says your total food quantity is placeholder, and we'll pass in food quantity, which is easily converted to a string by Rust. So now our total food quantity looks like it is 66. And if we, change the value here to something like 12, then we should have 68, right? So this is a really useful function because it allows you to take input items from some arbitrary collection and perform some kind of calculation to aggregate all of those items together into the accumulator. This is different from the reduce function because the reduce function actually automatically takes the first element of the collection, and that becomes the accumulator automatically. And then all of the additional items are processed within the reduce function. So it does behave slightly differently because you don't have the ability to specify your accumulator initially. Just whatever the first value of the collection, in this case, it would be this tuple right here, that would become the accumulator. All right, so I think the last one that I wanted to talk about is peekable. So peekable allows us to peek into a collection of items without actually advancing the iterator. Previously in our code, we saw how we can use the next function here to iterate to the next item within the collection of items, right? And the iterator is just tracking the internal state. So right now we're at item 0, then we call next, we go to item 1, call next again, go to item 2, and so on and so forth. But sometimes you want to look at the data without advancing the iterator. And to do that, you can call the peek method, but the peek method is not available on the iterator itself. Just take a look at the documentation right here for Rust on the iterator trait, and you'll see that we don't have a method here called peek. However, we do have a method called peekable, and this returns a peekable from that method. Now, if we go to the peekable type here in the module, in the iter module here, you can see that we do actually have a peek method on the peekable type, but we don't have it on the iterator. So all we have to do is call peekable on the iterator, and then we can call peek. So let's say that we wanted to get an item from this vec right up here, foods. So we'll do foods dot peekable. Actually, we need to do foods dot iter dot peekable because we need to get an iterator from our foods vec. And then we can just go ahead and call, let's say, next. And then after we call next, we'll peek at the second item. So we're advancing the iterator beyond the first item, and then we can peek at the second item without advancing it. So what we'll do is say let food equal whatever peek is right here. And then we'll go ahead and say print line peeking at food, and we'll just pass in or actually, in this case, it's going to be food dot 0, and that's wrapped in a option type. So we'll just do a unwrap dot 0 because that's the first item in the tuple is the type of food. And I need an exclamation point there as well because we're calling the macro. And we get an error saying temporary value is freed at the end of the statement. I think this is happening because we haven't created a copy of our data up here. So let's clone that. And then let's do a clone here as well. Not sure if that'll take care of it, but let's see. So I think what we actually need to do is take this peekable and assign it to a variable. I ran into this before. And then once we have the peekable in a variable, I think we can just call peek on that. And it looks like we are getting another borrowing issue right here. And this is just a borrow issue because it's not mutable. So let's make my peekable mutable. And let's see what we're getting right here. Creates a temporary value which is freed while still in use. So I think what I might need to do is create the iterator first and then call peekable on it. So let food iter equal this. So yeah, that works fine. And then if I do food iter dot peekable, yeah, that fixes the issue there. For some reason, I can't chain those methods together. But if we create the iterator first and then turn it into a peekable, then we can call the peek method here on our collection. All right, so let's go ahead and do a cargo run. And sure enough, it says peeking at potatoes. And that's because I am not calling next here. So let's do peekable, my peekable dot next. And let's see, cannot borrow as mutable more than once. We actually want to call it before we peek. That's why we needed to do that. And now we're peeking at strawberries. Yeah, so that's what I wanted. So basically we call next, that advances the iterator to the next item, which is strawberries. Then we peek at strawberries. And if we were to peek again, like let food to equal my peekable dot peek again, then let's do a dot clone here. And I'm not sure what's going on here. I need to figure out what's going on with this memory situation here. But basically, if we were to call peek again, right after we call peek, then we would still get strawberries because peek does not cause the iterator to go to the next item. It doesn't advance the iterator. It simply looks at the next item, or the current item, I should say, without actually causing it to advance to the next one. So anyway, that's how peek works differently from the next method, because next advances the iterator and peek does not. Anyway, there are a bunch of other very helpful functions in here. I didn't want to go over every single one because that would be an extremely long video, but I did want to show you a lot of the very useful common ones that I think you'll probably come across. So feel free to go into the iterator documentation for the iter module in the standard crate and check out some of these other methods that are provided by the iterator trait. Again, if you learned something from this video, please leave a like, leave a comment down below. Let me know what it is that you learned from this video. Let me know what other topics you'd like to see in the comments down below as well. Please subscribe to the channel and share a link with everybody so that you can help me expand this channel and bring you more great videos like this one. Thanks, and we'll see you in the next video. Take care.